This try to two stationary plates shaped as semicircle of radius r. I'll try to give some better diagram. This is what the gap between them is filled up by a dielectric slab. So now what we are going to do is one plate is fixed here. Three-dimensional, very difficult to show, no? I'll try to draw the diagram. We'll see. I'll try. So this will be the if you can get the diagram, it'll be very easy for you. You can solve it very easily. You can solve it. This will be the situation. So now this is that point to what he has given. No, leave it this much here. So what is a dielectric slab? That yellow color is a dielectric slab. Two plates are there. So this is what the plate, and the other side will be the plate. So go this one. So now it's asking what is the torque acting on the slab. So what is that slab? Slab is this one here. So just a plain diagram also you can manage here. So now how the torque will act, from where the torque will come. This is theta. Theta or any other angle. I'll make theta. That will be easier. Find the magnitude of moment of forces relative to the axis, so acting on the movable plate in the position shown in the figure. So the dielectric slab, what it is being done, it is being fixed to one of the plate. One plate is mobile, one plate is fixed here. So it is, that's what he is trying to show it here. No, let's get into the diagram. So I'll just make problem very simple. So there are two situations are there. So this yellow color one, I'll make it a dielectric slab. This was the dielectric slab, no? Here on I'll wind up. This is the thing. So that yellow color is what? The dielectric slab. So now there are two capacitors are there, no? So first, when it is fully filled up, let's take like this here. Initially, if you are able to get the diagram, it's very easy. So there's a thing, and that The dielectric slab is here. Initially it is fully inside. Let R be the radius. What is the capacitance of that will be? And the separation between the plates is D. This is what that D. No much information is there. So you make out all this one, and this is what that axis about which it's going to rotate. So fine. Okay, let's come further. What is the capacitance of this? Let me write C naught. What is C naught? Epsilon R. Yeah, we'll take the relative epsilon naught. So pi r square area, pi r square by 2, no? Half of this one. And the distance between plates is T. When slab is fully inside that semicircular plates. And what is the shape of the dielectric slab? Semicircular. It will exactly fit into this one. When slab is fully between the plates. Okay, there's a thing, that one. So now look at this. There's the air part, no? There's the air, and there's a part of dielectric slab. Break up into three parts. Part of dielectric slab. This is air. There is no slab here. So what about here? Slab, part of slab between the plates. So you give name O, A, B, and C. And D. OCD, will there be any capacitance? Yes, air capacitance. OAB, sector OAB, will it make any capacitance? No, that is a dielectric slab which will lie outside, no? Section OAB lies outside the plates. OCD, air. OBC is what? The slab part of a say, or a say like a part of a slab which is there between the plates. Can you make it out that one? I think this OAB will not contribute any capacitance. Is it okay? What is that OAB? So it's a diagram is here, like this is B, this is A, this is C, and this is D. So the one which has come out will not contribute any, that OBA segment will not contribute any capacitance, no? So here air is there. ODC will become air. So what is the capacitance looking at the diagram? Capacitance due to air, capacitance due to dielectric slab. Now the total capacitance here is C, will take it. What is the capacitance of this? C is equal to capacitance due to air plus capacitance due to slab. Capacitance due to air, it should be like. So this will be theta, area of the sector. So epsilon naught, area of the sector, theta r square by 2 by d. Then what about this particular area? How much remaining area we have to take it? CD is what? That particular thing, everything that will be. So shall we go for pi minus theta? This angle will be how much? Pi minus theta. So this will be epsilon naught, epsilon r, pi minus theta, r square by 2 by d. That's the capacitance due to the slab. Rest all mathematics. Initially, these equations, generating these equations is what the concept. Okay, just rearrange everything. So this, after rearranging, epsilon naught r square by 2, I can take common, no? Epsilon naught r square by 2d. This everything I'll take common. So 1 epsilon naught for C area is there, no? Epsilon naught is there, no? Okay, fine. So this should be equal to epsilon r minus 1. Epsilon r getting confusion, right? K. Theta will come. Yeah, theta plus epsilon naught pi r square by 2d. I'm keeping this much here. Check once equation. Okay, this is the capacitance of the system. So what was the earlier capacitance? So I'll subtract these two I'll subtract here. F naught pi r square 2d. So that will help you. So before that, let me go for it. Is there any external agent on its own will not come? No, the external agent will rotate the slab. He's asking find the magnitude of moment of forces related to the axis, so acting on the movable plate in the position shown in the figure. From this initial position, from this position to bring it to this open, the external agent should rotate that one of the plate. See what actually happening? One of the plate is fixed, the other plate, the dielectric slab is attached to it. The external agent should rotate, so it should the work done by external agent. So it should be like this. Huh? The external agent should apply torque here. Okay, got this one.
Sir,
It should do work.
in capacitance, it should be 1 minus ER. 1 minus ER.
No. This one, here. This, yeah. Yeah, fine. Okay, look at this. So the external agent should rotate, no? So therefore, he's applying a torque. So what is the question? I was like, find the like a torque exerted by the capacitor on the dielectric slab. First of all, why do it return back again? Why do it return back? Like similar to slab placed between the plates. So when you keep it here, what will happen? The capacitor will suck the slab into the plates. So from where this torque will come? So this, shall I say torque, this torque is due to electrostatic forces. Due to electrostatic forces. Now, why they should act? Again, the fringing effect of the capacitors is what you have to come into picture. The fringing effect. So here, if I show that fringing effect, it will be if there's a plates, no. So the field here will fringe out like this. If there's a positive plate, the lower one is negative, positive. The field here will fringe out. It is similar to binding book. Binding book, you'll be having that coil, no? Plastic spiral coil. The similar situations, what you can see here. The field will fringe out here. It will be like this. So when you bring out the slab, so this field will induce charges. Where do it induce charges? It will induce charges in this region. It will induce charges here. That induced charges, they'll exert a force. Due to that force, what happen? About 0.2, those forces, electrostatic force, will set up a torque. And that torque is what is asking. Sir, do we know nature of induced forces? We are not sure. It's not sure. It will be non-uniform also. So therefore, how to, since we don't know, sir, like a induced charge, the distribution, so we can't find out force. So we don't know force. So no question of torque. Okay, there is a thing about one way of thinking about the induced charge here. So let's talk about the energy. Through energy, can we find out the torque? Yes, we can manage here. So let's calculate the delta U. So initial energy of the circuit, how much it is? Because I'm applying a potential difference. A potential difference V is applied here, no? Lot of diagrams is what you are supposed to, or you do one thing, say finding very difficult. Just take two papers, cut them into semicircular part, inside below, in between that particular thing, you bring another some thick some thermocol, or nothing is available, you can go for some notebook, old notebook, cut that into semicircular part. That's what the system is, what we are discussing. Fine. So this about the fringing field, you write it here. This is a field fringes out. Fringes out means will not be confined only to the semicircular region, will just spill out. Okay, let's come for this one. Next again. So what is the initial potential U naught or Ui is equal to C naught V square by 2, which is equal to epsilon R epsilon naught pi R square 2D V square. What about the final potential G? So directly I should write equation equal to this much here. C epsilon naught R square theta 1 minus epsilon R by 2D multiplied by V square is there. I'll push it down. Let it right here. This is whole bracket.
Sir, U initial by 4 will also by 4 will come, sir.
I'll write it here. Okay, this is about the initial final potential energy. Why I'm bringing this again? See, in this case, it's having energy. Extra agent will first should rotate the dielectric slab. No, the plate with the one of the plate will rotate. For that, he should do work. So work done by him now is available as increase in potential of system here. So therefore, work done by extra agent in rotating the slab. Work done by external agent in rotating the slab only. I'll write it because the slab is attached to one of the plates. Let me write only slab here is equal to delta U. That should be equal to UF minus UI. So we know UF and UI. So some of the quantities will directly get cancelled, no? So only this left hand side in the bracket will be available. So this should be epsilon naught R square theta 1 minus epsilon R V square by 4D. I'll write it total. So this much is what the extra agent should do work to rotate the slab through an angle theta about the axis O. There's the meaning of that one. Okay, after this, but what was the question asked? The question was asked about the torque, no? From where to bring the torque?
Sir, he told he is maintaining a potential difference V. If we consider a battery, then that battery will also do work.
Okay, no problem here. I'll finish off in the end. You can ask it. Huh? Let me finish off. Okay, now this is about the work done by extra agent is there. Now, if I release it, so what that electrostatic forces, it will pull back that particular slab into the plates, no? So they'll exert a torque. So any torque and the work done by extra agent are related. So we know that torque into theta should be the work done. Can we also write in this way? Work done. If they linear motion, force into displacement. If they rotational work, then what we write? Torque into theta, that one. So work done per unit angle is what shall we call as a torque? This will be so here. So do we know value of this work done by I need some space. Come for this one. I'll write in next page. So what is the rotational work definition? Rotational work should be equal to torque into theta. So what is torque equal to? So this should be equal to how much? Epsilon naught r square 1 minus epsilon r v square by 40. You are supposed to do this much of work. So here, rather than this, you come in other way. Already it got displaced. Let's assume that one. If I release it, the electrostatic forces will exert a torque, will exert a force. Due to that force, a torque is set up about O, and what is the torque acting is this much. This is actually the reason I just brought it by the method like this here. Same, the idea of the slab in the capacitor is what we are just introducing here. So can you remember, like there we brought expression for the force, no? Here the expression for torque. See, this torque is independent of theta. You displace through angle 30 degree, 40 degree and release it, no? The same torque will act here. So shall I put that one? Torque is, this tau is independent of, this is what? About O, independent of theta. So what is our actually question? The question actually starts from here. What is that one? About O, there's a diagram. So look at the left-hand diagram. So there's a diagram is there. So what is the torque acting on it? We just shown the explanation like this here. Or you want to proceed similar to the dielectric slab, what we did know, you can use that also. Work done by the battery plus work done by electrostatic force equal to change in everywhere, everything will be same. You'll end up with the same answer.
Sir, why aren't we considering work done by battery here?
See, like here, I started like, see, what is the question here? In this position, it's there, the slab is there in this position, then we'll switch on the circuit. Then he's asked, what is the torque acting on the slab?
Sir, you took two instances. At one instant, the slab is at an angle theta, and at another instant, the slab is perfectly fitting inside that. So
That is,
the time taken by it, like the moment from where it goes back to that theta equal to 0 state, the external agent, the device what we are using to maintain that potential difference V, it will also perform some work.
see here again, say the method is just see like the method is like a work done by the battery should be equal to increase in kinetic energy of slab plus increase in potential G of the capacitor. The similar method you can apply here also. You'll get the same answer.
I'm not telling that, sir. I did that method. I got the same answer. I'm not complaining about the answer. But in this procedure, at some point, we have to consider the work done due to battery.
Yeah, I'm just interested only to get that torque. That's why I brought this method. I'm telling this one. The battery,